We are going to solve four different integrals here. For the first one, if we want to solve this integral, we can use substitution, and the expression that we use can be z cubed plus 1. You can try any other ones if you want, but this one works for sure. So taking derivative both sides, don't forget to write du, dz, or whatever d it is. And from this one, either we can say that we have z squared dz here, or if you think you will not recognize this, you may say that I would like to find dz from here, which will be du over 3z to the power 2. Both of them are correct. So either way, we would have, instead of z squared dz, would be du 3 all over z cubed plus 1 is u, and you can bring out the coefficient here. You're left with 1 over u du here, and we know based on the table that the integral of 1 over u du kind of same as 1 over x dx. It will be 1 over 3 ln of absolute value of u plus c, and since u is z cubed plus 1, we can rewrite it as 1 over 3 ln of absolute value z cubed plus 1 plus c. If you wanted to do this, that would be the same. You would keep z2 here. Instead of z cubed plus 1, you write u, and instead of dz, you would write du over 3 z squared. So these two uh, amounts will be cancelled, and again you would have 1 over 3 1 over u du, and you can bring this one out same as here. Number 2 is the integral of sine of x over 1 plus cosine of x. I would write cosine of u, cosine of x equals u. So taking derivative both sides, that would be negative sine of x dx, because the variable on the left side of the equation is x, and the right side is 1 du, that we usually only write du from here. So either way, you would have negative du over u plus u squared plus 1. So you can say that 1 over 1 plus u squared du. I can find this one in the table, and the answer would be negative tan inverse of u plus c. And since u is cosine of x, we are going to write tan inverse of cosine of x plus c, and that would be the answer. So number 3 is a definite integral. But in order to solve this one, we are going to solve it as an indefinite integral, and then we would put the limits here. So according to the properties of integral, I can rewrite this as 0 to 1 e to x dx, and I can bring out the coefficients. So negative 2, the integral from 1 to 0 to 1 x squared dx. The integral of e to the x is just itself from 0 to 1 minus 2 times the integral of x squared, which will be x cubed over 3 from 0 to 1, or you may write them all together. So if you would write e to 1 minus e to 0 for the first one, negative 2 times we would write 1 over 3 minus 0 for the second one, and altogether, since we know that e to 0 is 1, we're left with e minus 5 over 3 for this one. And we have one more here, which is another definite integral. It is the integral from 1 to 2, x minus 1 over dx over square root of x dx from 1 to 2. So I recommend to write it as 1 to 2 x over square root of x minus 1 over square root of x dx. It means that if you simplify, you would have x to the power 1 minus 1 over 2, which means 1 over 2 minus number 1 over x to the power 1 over 2, which is the same as x to the power negative 1 over 2 dx. So with this one, we're going to solve it together at once. So when the power is 1 over 2, you would add 1, you would get 3 over 2 over 3 over 2 according to the table, minus when you have negative 1 over 2, you would add 1, you get 1 over 2 over 1 over 2 from 1 to 2. But before applying those numbers, let's simplify it somehow. So for the first one, the reciprocal of 3 over 2 is 2 over 3, x to the power 3 over 2, minus the reciprocal of 1 halves is 2, and x to the power 1 over 2 from 1 to 2. So we would plug in 2 for x, that would be 2 to the power 3 over 2, which means 2 to the power 3 under square root, because nothing here means 2. So 2 to the power 3 means 4 times 2. It means 2 square root of 2 for this one. So you can keep it as 2 to the power 3 over 2 and then simplify, or you can write it right now and then factor out. So for the next one would be 2 square root of 2 when you plug in 2. Minus when you plug in 1, you get 2 over 3 minus 2 here. Since 2 to the power 3 over 2 is the same as 2 square root of 2, and this 2 here, multiplied the 2 here, you would get 4 over 3 square root of 2 minus 2 square root of 2 for the first parentheses minus the last one, which is 2 over 3 minus 2. Altogether, you can write it as negative 1 over 3, 2 square root of 2 plus 4 over 3. Or maybe you would put them together, and for the numerator, you write 4 minus 2 square root of 2. That would be correct also.